Okay, this is Chapter 11, Organic Chemistry, Lesson 3. In today's lesson, we're going to learn what an isomer is, and we will learn how to draw and name various isomers. An isomer is a compound that has the same molecular formula, but a different structural formula, and therefore it will have different names and different chemical and physical properties. You need at least 4 carbons in order to have an isomer. So, some examples: methane, ethane, propane. They do not have any isomers because there is nowhere to move a carbon. Methane only has 1 carbon. Ethane has 2 carbons. If I move it, it's still 2. And in propane, I can't move this C anywhere. In order to create an isomer, you have to be able to remove an end carbon and put it somewhere in the middle of the chain. So butane, which has 4 carbons, is actually the first molecule to have isomers. The larger the molecule, the more carbon atoms, then the more isomers that the molecule will have, because there's more than one way that you can then rearrange the structure to form something else. The first way is you have to make a branch. The second thing that you have to do is, so the branch is something coming off the parent chain. Then you have to move the branch. And then lastly, you need to possibly move a multiple bond. Now this is only if there's a multiple bond present to begin with, meaning a double or a triple. If you're dealing with a straight chain alkane that has only single bonds, you can't add a double or triple bond to it. You have to work within the constraints of the original molecule. So, very quickly, if I draw butane, 1, 2, 3, 4, so this is normal butane. What I'm going to want to do is take off an end carbon. So I'm going to just say I'm going to take off this end carbon and I'm going to move it right here. So what results is and you can see that I've moved that carbon right here. So these both have C4H10 for a molecular structure. They're both C4H10. However, this is butane, and as you know, this is now, we're going to number this so it gets the smallest number. So 2, this is going to be 2-methyl, because that's a methyl group that we moved, propane. Because now my longest chain is only 3 long as opposed to 4 long over here. Here's some isomers of pentane. Look what happens when we break off a terminal carbon. A terminal carbon is simply an end carbon. If I take off this carbon and I move it 1 over, oops, right here, okay, I now have 4 in my chain. Now remember, I have to number this from left to right or right to left so that my branch gets the smallest number. So I'm going to number from right to left so that the methyl group gets the number 2. If I number from left to right, then the methyl group would have the number 3. So this is 2-methyl. It gives me the location of the group, and I've got a 4-long parent chain, which is butane. Now I can break off another one. Okay, I'm going to break off this end one, and I'm going to move it here, which is what I did over here. Now my longest chain is 3. I've got methyl groups above and below on the second carbon. I have to name the location. This is 2,2, and it becomes dimethyl because they're exactly the same, and I have 3 carbons, so that's prop, and they're all single bonds. You can only make branches on non-terminal carbons. So let me show you what I mean by that. If I take butane This is normal butane, and I move this carbon, the end carbon, right here. It's going to look like this. Well, guess what? This was butane, because my longest chain is 1, 2, 3, 4. This is also butane, because all I did was bend the chain. So this is butane. This is not an isomer. All I did was bend it. Imagine a Twizzler and bending it. That's what I did. It's still butane. Okay, let's draw some isomers of pentene. Because pentene contains a double bond, it's going to have the formula C5H10, because the general formula is CnH2n, so if I have 5 carbons, that means I have 10 hydrogens. So we can do two things to make an isomer with pentene. We can either move the double bond, or we can break off a terminal carbon and put it somewhere else, or we can do both. So let's start by drawing pentene. So we have 5 carbons, and we know that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. So this is just normal pentene. Well, the easiest thing for me to do would be to move the double bond. So let's see if we just move it over one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now with these two H's, you can put them either on the top or the bottom, or one on the top, one on the bottom, so long as each carbon has 4. So now my double bond is on the second carbon, so this would be 2 pentene. Alright, so let's draw something new. Let's try moving one of the methyl groups. So let's start with the pentene where it was, and I'm going to take off a methyl group and I'm going to put it here on an interior carbon. I'm going to add my H's. So now I have the number, so my branch gets the lowest number, 1, 2, 3, 4. So I've got a methyl group, so it's 2-methyl, and on the third carbon I have a double bond, so 3 pentene. Okay, I can also move another carbon, so 1, 2, 3, 4. Let's put methyl groups here and here, and we can leave the double bond here. So now let's see what I have. 1, 2, 3, 4. Okay. So now numbering again, this is 1, 2, 3, 4. This is going to be 2,2-dimethyl, and it's di because I have 2 methyl groups, and my double bond is on the third carbon, so 3 pentene. And lastly, I need one more. Let's try putting the double bond on the second carbon, and let's also try putting a methyl group here. Four, 4, 1, 2, 3, 4. Okay, so here I have 1, 2, 3, 4. So this is going to be 2-methyl, and my double bond is also there, 2-methyl, 2-pentene. So that's a little bit about isomers. Got to make sure that you're moving to an interior carbon. You need to make sure that each carbon doesn't have more than 4 bonds, and you have to make sure that you just didn't bend the chain. Lastly, this has nothing to do with isomers, just FYI, this is not on the Regents exam. Aromatic hydrocarbons. Hydrocarbons that contain one or more benzene rings or closed chains in their structure. So benzene can be written like this, or it can be written like this. Notice benzene has 3 double bonds. And then another type of benzene, here you have not only a methyl group, but you have an oxygen. So this would be called 1, 2, 3 trimeth, and then the oxy, because of the oxygen, benzene. Now if I take the O's out, okay, I could take the O's out and I would have 1, 2, 3 trimethyl benzene. And the reason why we even mention this is because benzene was the compound that was supposedly found present in controversial quantity in Coca-Cola back in 2006. It is a proven carcinogen which causes childhood leukemia. Okay, that's it for today's lesson. Nice and short, just the way you guys like it.